Okay, so in 1.5, our essential question is how can you measure and classify an angle? Well, the measure part of it is right here on this protractor. This is how you measure an angle. You measure an angle by finding how many degrees it is. Okay, so this measure part, how do you measure? It's going to be right here. You use a protractor. So let me show you how the protractor works. Okay, right now, if you notice the zero on this side, on this left side, there's no line cutting through the zero. So they're not measuring the angle from the left. So we're not going to be using these outside numbers. Okay, because if the angle was coming this way, then we would be using these outside numbers because that's where our zero is located. But we don't have anything through that zero, so we're not using those outside numbers. Over here is the zero is where the line's through it. So the angles are all starting from this line right here. So they're actually using all of the inside numbers. That's why this angle is 35 degrees, because you're using the inside numbers and it's going up 10, 20, 35 degrees. Okay, so you're not using the 150 and 140 because you want to start where zero is. So in this case, zero is inside. And then you can kind of keep going, and then there's 65 degrees up here because you keep on the inside numbers. This line right here would be at 65. So you kind of see how they're measuring them using those inside numbers. Now you can also measure an angle that's not at zero, like this red angle right here, by just subtracting the two measurements. So on a protractor, the one side of the angle right here is at 35. The other side of the red angle is at 110. So if you just take 110 minus 35, then you can figure out what this angle is from here to here. It's going to be 75 degrees. 110 minus the 35. That 110 doesn't look that great. Let's fix that. But that's 110 degrees. So if you subtracted them, 110 minus 35, you get the red angle inside. Or you notice you could have added these two smaller angles together to get the 75. So that's, you could have done either one. That's actually called angle addition postulate, where you add two small angles together. You add 30 and 45 together and you get the 75 degrees. So you could have measured that red one in a couple of different ways. That's just a protractor. You're going to see protractors a lot if we, like I said, right by the door, there's a protractor inside of a pocket with your compass. And we measure angles, we use the protractors, things like that. Now, the first two pages of your journal here, 22 and 23, okay, these are all like your exploration pages. I don't technically spend a lot of time going through these. These are more for you to explore, even though I give you the answers. It's more like you can try it and then check them and see if you're doing it right, or if you just want to copy it down, you can just copy it down. That's completely up to you. I'm not requiring pictures on those. Just those are it's called an exploration because they want you to explore. So some of them are not written down because you're supposed to do stuff on an index card and things like that. So more of it for you, your chance to explore the different concepts that we have. So I'm going to go straight to the vocabulary. So 1.5. And you can see that we're going to talk all about angles in this section. So the first word, of course, is angle. And angles are two rays. And that's just what we drew on our construction. We drew the first ray, then we figured out how wide the angle was, and then we drew in our second ray. So that's exactly how you make an angle, is you draw two rays. And the two rays have to meet at one point, and that point is called the vertex. So that would be that's your first word, and that's your second word together. The two rays we drew, and the vertex is the point where they meet, and the sides of the angle are the two rays. So they're just called sides of an angle. Interior and exterior, the best way to just show you that is to show you the picture on the next page, the picture where the protractor is. You can see when you're measuring an angle, in this case the angle was 140 degrees, because again it started on the right side, so we used the inside numbers. The interior of that is where the 140 degrees is. It's between the two sides. The exterior of that is on the outside of the angle, the side that's not getting measured. And then the vertex is, of course, the center point. O is our vertex. And the sides are the two rays. Sides are the two rays. Now, the measure of an angle, which is the next one down here, the measure of an angle is how many degrees it is. So this has a degree angle of 140. So the measure of that angle is 140. But I want to show you there's a couple of different ways that we can name angles. Okay, we could name angle. In this case, we could name it like two or three different ways. Okay, we could call this angle up here angle O, because you can always call an angle by its vertex. So if O is the vertex, you could say that's angle O. You could also call it by the points that are on the angle. So angle A through O to B, and the vertex would always be the center point of those three. So angle AOB is another way to name that angle. You could also switch the A and the B around, and it could be angle BOA. O is going to have to stay in the middle, though, because O is the vertex. So different ways to name angles. The next four terms are all on the pictures across, so I didn't spend the time writing them down because they're right there, but you've probably seen them many times before. Acute angle is between 0 and 90. Less than 90 degrees is acute. It's acute little angle, is what they call it. So they're acute. Right angle is exactly 90. And then classify, as the word classify here is give it a name. What is it called? So that's why they're giving you these names. So the right angle is 90. The obtuse angle is between 90 and 180. And then the straight angle is exactly 180. So a straight angle is a straight line. You can see that's exactly a straight line. And you'd have 180 degrees across the top. You'd have 180 degrees across the bottom. And of course, 180 and 180 is 360. So that would be all the way around. But a straight angle is straight across. We do have angles that are more than 180, and they're called reflex angles. So reflex angles are going to be in our trig book, so we're not going to have those just yet. The bottom two vocabulary terms there, you've got congruent angles, which we already know by congruent segments. Congruent angles are the identical angles. They're the same measure. If they're identical, they're congruent. That's exactly what we just constructed today was congruent angles. We just made them. An angle bisector is a ray that cuts an angle in half. So if you cut an angle into two congruent angles, then you have an angle bisector. And we usually just use arcs to show that they're congruent. And let's see, last thing on this page right here is your angle addition postulate. I kind of already showed you that on that first protractor, where if you add two smaller angles together, you get one bigger angle. So if you notice, I numbered them in there, angle 1 and angle 2. If I add angle 1 and angle 2 together, I'll get the big angle, which is angle 3. So adding two adjacent angles makes one bigger angle. We just add them together. Now, you might have to subtract. If they gave you the big one and one of the small ones, you can subtract to get the other small one. So whether you're going to add or subtract just depends on what they give you in the problem. So that's your angle addition postulate. Now, like I said, if you still need to stay on this page, then you would want to be in your own little tab, and you can stay there. I'm going to move to the extra practice. Page 26 is one of the pages you got to take a picture of. So you're going to have to make sure you have it all down on your paper and take a picture of it. And it's way over here. I just did one each period, so that's why I covered those other ones. I forgot to cover that one. My bad. Let's do that real quick. That. Okay, because that'll get distracting, I think. All right, let's go to page 26. So we want to first name three different angles in the diagram. So we want to find three different angles. So one angle starts with, we could start with E, and it goes from E to F to G. That could be one angle. So I'm going to put angle EFG. Another angle could be the starting at G, going to F, and then going to H, so GFH. The last angle would be the big angle with those two put together, E to F to H. So angle E, F, H. Notice that all three of those have F in the center because F is the vertex. F has to be center, F is the vertex. So that's how you would name three different angles. You have the small one here, you'd have another small one, and then you've got the third one is the big one. So in this case, you got the small one here, which would be angle QRT. Then you'd have the other small one, which would be TRS. Noticing R has to stay in the middle. And then the big one would be QRS. Now, I could have started on the other side and did SRQ, same thing, as long as R is in the center. Number 3, your first angle is LMN, if you do that NS first, LMN. Your second one would be NMK. And then your last one would be LMK. So that would be those would be your three angles. This would be the big one here would be your third one. That's just naming angles. The best way to name an angle is by using the points on the angle and the vertex point always in the center. The next ones we look for clues. So we want to say, okay, find the indicated angle measures. They want us to find JKL, J to K to L would be the big angle. They want this whole angle. So the clues are that they gave us the two small angles, 31 and 85. So we add 31 and 85 together, we get 116 degrees. So we could put the measure, little m means measure of angle JKL equals 116 degrees. It's equals because we're talking about a number, 116. So that's number 4. Number 5, the clue is right here in the problem. Measure of angle R to S to U, which is the whole angle. This whole angle is 91 degrees. The bigger of the two inside is 69, so they want us to find the smaller one inside, this question mark right in here. So we're just going to subtract 91 minus 69, we're going to get 22 degrees. So the measure of angle RST equals 22 degrees. Because we had to take 91 and subtract the 69 to get the other piece. So that would be your second one. Looking for clues, always looking for a clue. In the number 6, the clue is straight angle. Right above that, I would put 180 because that's what a straight angle is. That's what it adds up to. So if I know that this angle is straight, that means that I know that those two together add up to 180. That's what's happening in the problem. So that means x plus 20, okay, that angle plus the other angle of x equals 180. Those two angles together add up to 180. So you would combine your x numbers and you would subtract your 20 on both sides. So you would get 2x equals 160. When you divide by 2, you get x is 80. Now be careful because a lot of people like to just throw in 80 as their answer, but look what it's asking for. The measure of UWV, which is the one angle, and it wants XWV. So you got to plug in the 80 into both. 80 plus 20 tells me that this one angle is 100 right here. So this angle right here is 100. Let me put it inside, get rid of this 180 right there. So this angle is 100 right here. Very touchy right now, very touchy. And then 80 is just x, so there's your 80. And you can double check to make sure it's right by adding them together, and it should add up to 180, which it does, 100 plus 80. So that would be 6. 7, again, looking for clues. Clues. The clue right here is the right angle box. Right angle box means they add up to 90. Okay, so I'm going to add those two to 90. I'm going to take the 5x plus 57, and I'm going to add to it the x plus 15, and I'm going to set them equal to 90. In this problem, your first angle plus your second angle adds up to 90 because they're a right angle box. So I'm going to combine my like terms. I get 6x plus 72 equals 90. 15 and 57 is 72. And then if I subtract 72 on both sides, I get 6x equals 18. If I divide by 6 on both sides, I get x is 3. So 3 is my x. Now what is it asking for? CAD, which is this angle right here. So if I put a 3 in there, I get 18 degrees. Okay, so there's one answer. And it's also asking for angle BAD. So B to A to D is this bigger angle. So you could put a 3 in here too. 5 times 3 plus 57. You could also subtract 90 minus 18 because we know the two angles together have to add up to 90. Either way, you're going to get 72 degrees for this angle. They both come out the same answer. So that was 7. 8, the key word or the clue that we need is bisect. Bisect means cut in half. So EG is cutting the angle in half. It's making this angle right here equal to this angle right there. And the whole thing is 92. That's what they're telling us there. The whole thing is 92. So if I want to find out what the two smaller angles are, DEG and GEF, then I just need to take that 92 and divide it by 2. You're going to get 46 degrees for both angles. So this angle's 46, this angle's 46. Bisect means you're taking the whole thing and cutting it in half, and it's making two equal pieces. So 92 divided by 2 is 46. The last one has a keyword, bisect again. And this time, since there's no number, there's variables. We need equations. Bisect, is going to make equal pieces. So bisect technically is going to mean equal. When you see variables in a problem and you see the word bisect, you know it's going to be equal because it's cutting in half. So that means the 4x minus 10 is going to equal the negative 3x plus 130 because they were bisected. They were cut into equal pieces. So you could add the 3x since it's the smallest and you want to keep x positive. You want to add 10 to move it to the other side. So 7x equals 140. When you divide by 7 on both sides, you're going to get x is 20. And it wants us to find PQR. This is this first angle right here. So if I put in a 20, 4 times 20 is 80. 80 minus 10 is 70 degrees. Okay, so that's 70 degrees. The other angle it wants is PQS. So P to Q to S, the whole big thing. Okay, well, if one of the angles is 70 and we know they're equal to each other, that means this one's also 70. And they want the whole big thing, so 70 plus 70 would be 140 degrees. So that big one would be 140. 70 plus 70 together makes 140. So there's your 1.5. There's page 26. So that one you'll want to take a picture of and attach to the assignment on Classroom. And that's just going to walk you through all the angles. It's going to walk you through naming angles, angle addition, subtraction, and bisecting angles and right angles and stuff. So those are just the first part of that's 1.5. First part of your assignment is to take a picture of that page. And then we want to go to 1.6. 1.6 is a little bit shorter. There's just 5 key pairs that I want you to see, because angle pairs are very important in geometry. Angle pairs. So there's 5 pairs that I want you to look at. And those 5 pairs are on your vocabulary. So go straight to your vocabulary, page 29. Go straight to page 29 and 30 on your journal. Go straight there. And I want to show you the different pairs. There are 5 different pairs. Okay, so I'm going to erase this stuff. Okay, so first pair is called complementary. It's a complementary pair of angles, meaning 2 angles. Pairs are always 2s. 2 angles that add up to 90. So that's why I put a big number 90 next to it. And I gave you an example up here of like 10 degrees, and then you'd have to have 80 degrees because we want them to add up to 90. If you follow the red arrow down to the bottom here, you'll see 2 examples of complementary. You'll see the right angle box right down here. And then you'll see the ones that are not right angle boxes, but they still add up to 90. One's 20 and one's 70. So that's another example of 2 angles that would add up to 90. Angle 1 and 2 would also add up to 90 because you see that right angle box. Both of those are examples of complementary angles. They have to add up to 90. Pair number 2 is supplementary angles. Supplementary, and that big number is 180. You need 2 angles that will add up to 180. And 180 is a straight line. So we need 2 angles that basically make a straight line when you put them together. So you can kind of see that in this example right here, is that 3 and 4 together make a straight line. If you put angle 3 with angle 4 together, you get this straight line right here. There's your 2 different angles. Angle 3 put together with 4 makes a straight line, called supplementary because they add up to 180. They add up to a straight line. So how do you remember the difference between complementary and supplementary, and which one's 90 and which one's 180? I use alphabetical order. Alphabetical order puts the C in front of the S. Since C is in front of S, then 90 has to come before 180. So C matches with 90, S matches with 180. Just the way I remember it. So that's the first 2 pairs. The third pair is called adjacent. You've already seen them in the last section where the 2 angles were touching. Like you can see, I gave you a little picture up here where angles 1 and 2 are sharing a side. They touch, they share a side. So that's really what the definition is. 2 angles that share a side, they touch. If you look at the example over here, you see that angle 5 and angle 6 share the common side. There's a common vertex, there's a common side. Here's non-adjacent angles over here. 2 separate angles, they don't touch at all, they're non-adjacent. So that's your third pair. Your fourth one actually has the word pair in it, linear pair. It's basically taking the supplementary and the adjacent and putting it together and making a linear pair out of it. Because if they add up to 180 and they touch, then they're going to look like this number 3 and 4 down here, and they're going to be called a linear pair. Linear means line, pair means 2. So it's a pair of 2 angles that make a line. And you can see the red arrows going over here, and it's showing you the linear pair right in here. Angle 1 and 2 are going to be put together and make this straight line right here. So that's a line, and it's a pair of angles because they share a common side. So we call that a linear pair. And it's just exactly what the 2 words mean. It's line pair, a line pair, a pair that makes a line. The last pair is the vertical angle pair, and they're congruent. That's the key thing about them, is they're congruent. They're identical. They're 2 angles that are across from each other when 2 lines intersect. So you can see this squiggly arrow going way over here to these vertical angles over here. 3 and 6 are called vertical angles because they are across from each other when these 2 lines intersect. Angle 3 and 6 are congruent. So because they're vertical, we could actually put the congruent symbols in there because they are identical. 3 is identical to 6. 4 is identical to 5. They're across from each other. They are identical. They're called vertical angles. That would be the basic part of your notes there, just to have in 29 and 30. That's all of your concepts. We're going to practice these concepts on the extra practice. This is what we're going to try to apply, these angle pairs. So we're going to move to, and again, you have this link. And I did forget to show you that. On the website, if you go up to the home page now, I did add, underneath the home page, I added the student journal. Right here, Geometry Student Journal is underneath the home page, and you have all of the Chapter 1 sections in there. So if you want to see any of the journal pages, you can click on any of those links and you can get to those journal pages. So that's underneath the home link, you've got that little drop down. But let's go to the last page, page 31 for today. So this is the second page that you will be taking a picture of. This 1.6, page 31. Okay, name the pairs of adjacent complementary angles. Okay, well, there is only one, so I'm going to cross out of this S because there's not two. Name the pair of adjacent. Okay, so think of the word adjacent. Adjacent means touching. So they're going to touch. They're going to have a side in common. And complementary means they're going to add up to 90. So I need two angles that touch and add up to 90. And there's only one pair that actually does that. If you look at those pictures, you probably see that one pair, hopefully. You're going to look for two angles that add up to 90. So it's got to be a 75 and a 15 because you got to be less than 90 so they can add up to 90. And those two are adjacent because when you draw in that 90-degree angle, they share the side OT. They share OT. So the two angles that are adjacent and complementary would be angle SOT. That's my 15-degree angle. And angle TOP. That would be my 75-degree angle. Those two angles are touching because they have OT in common, and they add up to 90, because 15 and 75 equals 90. And I'm going to cross out the word the in the second one and just put A, and I'm going to cross out the S. We're going to name a pair of non-adjacent. That means not touching. And supplementary means they add up to 180. So they don't touch, but they add up to 180. Two angles that don't touch, but add up to 180. So I'm thinking I could probably use one angle from one diagram and the other angle from the other diagram. That way I make sure they don't touch. So if I need the one angle, I'm going to have to use this 105 right here. So angle LJM or MJL, either way, I'll just go alphabetical. So I'll do LJM. Okay, that would be my 105-degree angle. So I need an angle that makes that add up to 180. So I need a 75-degree angle. I could use TOP again if I wanted to, because that was 75. But I might as well use this other 75 since I haven't used it yet. So ROQ, angle ROQ would be my 75-degree angle. Those two angles add up to 180, so therefore they are supplementary. They don't touch, but they still are supplementary because they add up to 180. So that would be 1 and 2, just looking at the clues that they give us. 3 and 4, we got to look for the clue again. The clue here is complement. Complement is the C one, so that's 90 degrees. C comes before S. So 90 comes before 180. Here's your S one. That's the one that's 180. So if I know that angle A is a complement of angle B, that means angle A plus angle B equals 90. They're complements. Angle A is 36. We don't know what angle B is, but we do know they add up to 90. So all you have to do is really subtract 36 from 90. So I could have just done 90 minus 36 and got my answer. So 90 minus 36, angle B, and I'll put M, little m, measure of angle B is 54 degrees when you do 90 minus 36. So subtracting them gets you your complementary angle, subtracting it from 90. Now, supplements add up to 180, so angle C plus angle D together is 180. So I know that angle D is 117. I don't know what angle C is. So I just need to subtract that from 180. So subtracting 117 is going to give you the measure of angle C is 63 degrees. 63 degrees for the measure of angle C. So those were just clues, looking for the clues. What word is in the problem? What matches up with that word? Since supplement was in the problem, then I need a 180. 5 and 6, once again, looking for clues. So I'm looking at number 5 and I'm seeing a right angle box, just like we had last section. So that means these two add up to 180, or not 180, 90, because there's a right angle box, it's 90. 10x plus 22 plus 7x plus 34. Those two angles together add up to 90. So I'm going to combine like terms. So I get 17x plus 56 equals 90. If I subtract 56 on both sides, like I said, we do a lot of algebra stuff. That's why we reviewed the first week. We're going to cancel that. You get 17x equals 34. And then dividing by 17, you get x is 2. Then you look back and see, what is it asking for? Well, find the measure of each angle. So that means I need to put a 2 in here. 10 times 2 is 20, plus 22 is 42 degrees for this angle right there, 42. So I could plug a 2 in here as well and solve it, or I can just do 90 minus 42, because I know they have to add up to 90, which gives me 48. So either way, if I plug a 2 in or if I subtract 90 minus 42, both ways I'm going to get 48 degrees. So those two angles, 42 and then 48. Adding them together, we get 90. Number 6, the clue is a straight line. Straight lines are always going to add up to 180. So these two angles together add up to 180. So 6x minus 5 plus, so that's one angle, plus the second angle, 12x plus 5, equals 180. Those two add up to 180 because they make a straight line. So combining like terms, the negative 5 and the positive 5 just cancel out. So 18x equals 180. And then when we divide by 18, you get x is 10. So x equals 10, and then we plug those in. I think 10 is easier to plug in than subtracting. So 6 times 10 is 60, minus 5 is 55 for this angle. And then 12 times 10 is 120, plus 5 is 125 for this angle. So I think plugging them in there was faster, just because multiplying by 10 is easy. Just add a 0 to it. So that was 5 and 6. The last 3 are simply I'm looking for pairs. Looking for pairs. Identify linear pairs that have angle 1 in it. So 1 and 2 is a linear pair because 1 and 2 together make a line. So angle 1 and angle 2 would have a 1 in it, and it would be a linear pair. There is one more that has a 1 in it, and that would be 1 matching up with 4. 1 and 4 together would also make this diagonal line. So angle 1 and angle 4 would be your second linear pair that has a 1 in it. There's lots of other linear pairs. 2 and 3 is a linear pair. 3 and 4 is a linear pair. So lots of other linear pairs. Remember, a linear pair can only be 2 angles. So I can't go ahead and say, oh, 5, 6, and 7 make a linear pair. No, 5, 6, and 7 add up to 180, but they're not a pair. There are 3 of them. There's not a linear trio. Sorry, it's linear pairs. So you're just looking for 2 angles that add up to 180 that are a straight line for a linear pair. Vertical angles, you're looking for the ones that are across from each other, and there's a bunch of vertical angles. So angle 1 is across from 3 when the 2 lines intersect. So 1 is angle 1 and angle 3. 2 is across from 4. I'll put 2 arcs and 2 arcs. The 2 arc would match with a 2 arc. The 1 arc matches with 1 arc. So angle 2 and angle 4. That's a vertical angle. And those are all congruent angles. 5, 3 arcs. 6 and 8, 3 arcs. Those are also across from each other when 2 lines intersect. So you could say angle 5 and angle 8 would be a linear pair. Angle 6, 4 arcs. Angle 9, 4 arcs. Because those 2 are across from each other. Angle 6 and angle 9. 7 and 10 are also, but I'm not going to go ahead and do 5 arcs. I'll just list them. Angle 7 and angle 10. So you have actually 5 vertical angle pairs. And each pair is a pair of congruent angles. Let's look at the last one. I'm going to change the color, and it says, are 6 and 7 a linear pair? So if I put angle 6 with angle 7, does it make a straight line? And if you look at my yellow angle on there, it's definitely not a straight line. It's definitely an obtuse angle. So you would say no, they do not make a straight line. They do not make a line, I would just put. They do not make a line. So they can't be a linear pair if they don't make a line. Okay, so that would be your 1.6. That's your page 31. That is the other page you need to take a picture of. You need to attach both of those pages to that Google Classroom assignment and turn that in.